Well, before I start, I thought I'll put a PPT as well. But before I start, I just wanted to, if you can't record at this point, I just wanted to see a show of hands. How many engineers in this particular room? How many? बहुत ही थोड़े हैं यार. This is an engineering college. All right. When I passed out, it was an engineering college. But I think we can record now. I think so no problems. I think I'll tailor my pitch to a certain sense in terms of what we are doing on AI, what's the latest, and maybe plant a seed of innovation amongst engineers and non-engineers alike in terms of where the possibilities are. And that's why the topic of my talk is when machines can imagine and what machines will imagine with you in terms of what we are doing. But before I start, I want to give my absolute regards. It's absolutely brilliant to be on this stage. This is my alma mater. I have passed out of this college for since 26 years, and I'm now coming back to this college to actually speak about the first TEDx, which is a great honor for me. And also thank you to this university for having grown to such an extent to what it has at this point in time. So that's a round of applause to this university as well in terms of what we do. I obviously did my engineering over here, and then I did my MTech. I went to Australia, did my master's in distributed computing, and then I joined IBM, and I was part of the very early team in 2002, which was working on Watson. So everybody's heard about IBM Watson. I think it was the first time as my triest with technology, with natural language processing, so that I can make machines work with human language as well. And it's been almost now about 20 to 23 years that I've been researching around language and trying to figure out various facets in how AI can probably increase human life as well. So I'll give you some examples over there. Before I start on what machines imagine, I want to give you a short story in my lab what we did. Everybody's played the Nokia snake game. The snake grows as you eat up a lot of food over there. So we actually made an AI system in our labs. And we asked the snake to grow as many times as it wants to, and we left the machine open for 24 hours. The only thing that we gave the snake was 4 suggestions. Move up, move right, move down, move left. 4 conditions. You can move around in anywhere, you should not touch yourself in terms of what you do. And then we let the AI to imagine itself in terms of what it wanted to do. When we came back in the morning, even though the direction given was only left, right, top and down, the snake was actually moving in a zigzag fashion. So it started moving diagonally as well. That's the power of emergence of AI. We had to shut down the machine because we didn't want to go forward with this particular program. But that's the kind of imagination of machines which is now slowly going to hit you in the new emergence of AI in terms of what you're getting in. So, sorry, when I go ahead, right, this power of imagination, we've for the last 20 odd years, we've managed to make machines that actually predict everything, maybe cluster things together, maybe segment if it's a right or wrong, maybe tell you whether you're wearing a red shirt or a blue shirt, etc. Give them vision to understand objects. Very in a big way, machines are now coming up where they're giving you emergent behavior, where they're imagining things as well. And that imagination is largely changing how human imagination is also working. They're becoming more collaborative. They're becoming more as co-workers. They're also sometimes becoming dreamers as well, to their own records in terms of what we do. If you don't know this, this is the famous Go game that is played in large parts of Southeast Asia, in China, in Japan, etc. And the game is largely played with 2 players. The 2 players, one of them has a white stone and the other one's a black. The whole idea of this game is to probably take as much territory as you can. Now, for centuries, this game has been taught and thought as only human cognition and intuition, because you are looking at that system and you're trying to figure out where should I take this system itself and take that territory, etc. And as compared to chess, right? Chess has got 64 squares. This has got 19 across and 19 bottom. The number of combinations that this game has is 10 raised to power 172 for one move. I can have as many as an astronomical amount of combinations before I make my first move as a human, right? And that's why it's supposed to be only played by humans. There was never a machine that could play this game because the search space is too large for the machine to search in 10 raised to power 172. This number is actually bigger than the number of stars in Milky Way galaxy. So machines were never taught to actually think around these lines. Lo and behold comes 2017, when this machine played one of the finest players of Go in China. His name was Lee Sedol. He was supposed to be a master of his craft, and suddenly the machine gives a move at move 37. And the reaction from Lee Sedol is this. And the reaction is, this move has never been seen before. No one in the history of Go and playing of Go game has actually made this move. No human player at least. But an AI system made this move and won the series 4-1 from Lee Sedol. This was the starting point of emergence of AI. And we normally consider 2017 when machines started really thinking aloud in terms of what they can do. This is one of those moves that has been recorded in the history of AI as one of the most pivotal moves. And now this move, 37, is being taught to a lot of Go players to actually consider occupying territory when you are actually in a losing position. So the machines imagined, but the human being really learned in terms of what we are doing over there. So this is an example of what happened on Go. Three revolutions are converging, and obviously you can see on the screen, right? How can machines become more imaginative than just being predictive? That's one revolution that is happening. The second revolution is from just mere automation that you see across the world, like robots, like things that you work in your GitHub Copilot. Like for example, if you have a script that runs, how can they do co-creation as well? And how are they becoming more collaborators in terms of the tools that you do, right? So these three revolutions is something which is actually changing the world in which we do. This is a story of a serpentine gallery in London. The artist over here, Rafiq Anadol, he actually wanted to make AI do the painting. So people say we can do anything and everything with machines, but we cannot give them creativity. That creativity seems to be a human right as well, in terms of what we think and do. So what he did was an interesting experiment. He took about 500 million odd imagery from the system, and he gave it to the machine and he said, do make an art for me, for this gallery. And it is his own words. He said the machines didn't produce creativity, they were hallucinating. And when they created that hallucination, something very interesting came out. He thought as if his co-creator was imagined. It was as if it was dreaming synthesis. It was dreaming forms. And what came out is now in the gallery. If you notice this is a photo from Rafiq Anadol. This has got no single human input. This is largely generated by machines out of those millions of photographs, and is now a part and parcel of the gallery in which you see. It imagines something which human beings can never produce in their own lifetime, right? This is another one. This is where we gave a kind of life to the ocean or the water world. He asked the machine to create something new. This has now become part of the gallery where machines have imagined a completely new face, right? So this is AI, artificial intelligence, imagining it. This is one scenario. The second scenario is obviously we are talking about healthcare. And one of the biggest challenges, and of course we've got a doctor in the room as well, one of the biggest challenges that we do today with healthcare is not just about patient care, but also creation of new molecules for drugs. And this is important because the world that you see today is now baffled by a lot of cocktail of viruses and bacteria that affect human life. Even today, when you get a disease and you go to the doctor, even if you've got a viral infection, the doctor would actually, give you an antibiotic. And when I asked him, he said, why did you give me an antibiotic? He said, sir, pata nahi kaun si cocktail hai. Ab ho sakta hai virus or ho sakta hai bacteria, I have to give you something. So he actually gives me an antibiotic over there saying something will be subsided. We don't know what's the real cause because we can't enter the human body. Now that's where machines are imagining the new future. I was very lucky and I'm so proud that we actually did this work during COVID. Of course, you had heard the story of COVID on one side where the patients were also, there was a big effort from the community to do patient care. Most of you have also taken vaccines, and if not all, you have been part of that vaccine generation where 3 steps were given. Very few people know that there was another effort that was being done during that time, which was formulating of a therapeutic molecule to enhance this. That therapeutic molecule comes from my lab. And that my lab worked for 1.5 to 2 years in that COVID time during 2020-21, where we actually used AI systems to find out a molecule that will attack the virus. By the way, we also found Ayurvedic drugs that can attack the virus. If you notice ashwagandha has a very interesting molecule called vidofrin A. The molecule is so advanced that it could attack the virus. And there is giloy. I think people would have told you, please take ashwagandha and please take giloy because it will boost your immunity. We have scientific proofs why those molecules would have prevented you in terms of those attacks from this virus as COVID. And COVID was a changing virus. It was a ribonucleic acid which changes faster. So we needed to have that kind of a mechanism. So that story was that we started looking at amino acids. If you are a bio person in this room, we started looking at how amino acids fold. We also started looking at how amino acids attack the virus vector. At one point in time in Pune on the National Immunology Virus System, I was knocking their door and saying, please give me virus. And they looked at me up and down and said, sir, aap kaun hai? So I very nonchalantly said, I am the Chief Innovation Officer of Tech Mahindra. So he said, so what? We can't give you viruses. So I actually held the biohazard in my hand for some time because I had to shift it to Bangalore to actually get tested of what I had found as molecules. And that of course went and created one single molecule that is today a patent in the name of Tech Mahindra that we are actually working as Baker's Lab. But this is what one thing that the machines are imagining. This is another example. It's a 50-year-old scientific question. If I give you amino acids, can you tell me how the proteins will fold in nature? And if you look at your body is largely consisting of, the functioning of the organs is largely because of proteins. Why is the liver shaped so and why should the liver function the way it has to? Is because of these proteins. So if we know how to generate proteins, we also know the cause and effect, what causes those proteins to go bad. So this is an example of Google DeepMind, AlphaFold. 50-year-old scientific challenge was solved by AI. The proteins that they fold today by only the amino acid sequence is better than any doctor or human being who can actually do this in the world. And the person who's actually done this has won the Nobel Prize of 2025. His name is Demis Hassabis, along with his people who started DeepMind. But imagine AI not only creating value for human life, but also giving that that advantage to that human being who started looking at AI and using it from an AI functionality as well. So this is one of the other examples that he has imagined. Obviously everybody knows this. If you don't, this is the car Waymo from Google itself. It actually practically, and there is no 2 points about it, it practically runs in San Francisco, California. And I have a video where I'm actually sitting in the car and it's a driverless car. The problem with San Francisco, like any other city that you find in Delhi or India or whatever, is that there is no restriction to the road structure. Right? So roads can move up and down, roads can be wavy, traffic can travel from here and there. But I have seen people beyond my generations, older, having full trust in an Uber car. When you open your Uber app, you can actually call a Waymo. The car comes in and settles down on the side of the road. It's driverless, nobody's driving it. It waits for 2 seconds or 2 minutes, whatever is the norm for Uber. You go close to the car, open up your app and say, open. The handles come out. You take the handle out, you sit inside the car. Your information is already fed. The car starts. And the way it maneuvers is as if an imaginary driver is trying to drive the car. And how I noticed this was, I was very particular in noticing it. When we stop at a red line or a red light, and you have a car in front of you, there's a human precognition to always keep on putting the accelerator. That I'll start now, I'll just go a little bit ahead so that the other car moves ahead. It does exactly the same. It was exactly doing the same thing, and I actually caught it on my camera saying this is human precognition built into AI. That there was a car in the front, it started to move slightly ahead. I said, "ये तो बिल्कुल आदमी कर हम करते हैं तो." So that was the story that we did, and it maneuvers the cars absolutely brilliantly. So that's one of the other cases where cars are imagining AI. Of course, doctor told you about prosthetics, orthotics for for patients who have lost their limb. One of the biggest challenges over here, and he can accrue to it much more better, is when you put an external system into a human body, it's not just the physical connection that happens, it's also a neural connection. And in that neural connection, you have to make sure that your patients are ready before they take that neural connection in. There's a lot of test, there's a lot of simulation that happens. AI and machine learning is actually helping patients do that kind of simulation. So we are producing haptics where people or amputees are actually taking their hands, they're putting it on a piece of system, and we are trying to give them that haptic feedback when an external body will come and touch. What will be your reaction? And that's another way where AI is imagining the next step of surgery in terms of what maybe also, the prosthetics that we actually do. Or most of your developers in our college over here and also in the IT world obviously know this. GitHub for code development, a large part of the code. Actually today we don't need developers, to be very honest. If you notice the IT world, if you've started working on Java and C++ and Python, please restrict yourself to only the coding language format, because rest of the work is taken care of by AI. I can write a very simple prompt and your whole application would actually be built up by AI in just a matter of minutes or seconds. Having said that, the reason why we need developers today as well is because AI tends to hallucinate. It also tends to go bad on the code sometimes. It doesn't stop where it has to stop, so you need an expert developer to obviously be there. But it's kind of a partner for you to in terms of changing it. But I told you how AI does well, but current AI still sucks. And that's the dichotomy. It's still not there where it has to, and that's been a part of big research of last 20 odd years that I do. AI has done magnificently well, it's won games, it's given you all these tools for development, it's given you tools for things that you today see, it still sucks. And why it sucks is basically because of this. It requires a lot of samples to train. And those samples are not very common amongst all the things that you see around the world. These data is probably one of the biggest linchpin that we see. And specifically if you work in India and Indian subcontinent, this data even becomes lesser, even though India is supposed to be the hot pot of every data that you see. But the problem is that the data is not structured in format that you want it to be. And as a result of that, AI starts sucking. Anyways, if you go to the Western world, this data is obviously less. And that's why they try and bring it into a kind of structured field. The other one is, I won't go into details, but there's a concept called reinforcement learning. It fails a lot of times in terms of what we do. Auto-regression. Then auto-regression is a system which today's ChatGPT and you've been using. All of you use ChatGPT. You put your question, it gives you the answer. You know why it gives you the answer? The only reason it gives the answer is because it predicts the next word only. The problem is, it's probabilistic. It's like a stochastic parrot. If the word prediction does not go right, there is no way that this AI would be brought back to terms. It goes bad, that's why it's called auto-regressive. It just does a regression path of its own, and that's why those LLMs are a problem. Whereas human beings, we know the world around us. A cat can actually do much more than a machine can do today in your house, right? Or your pet can actually do it. You also see humans' behavior is driven largely by objectives. If you have an objective in life, human behavior moves towards it. If you're a very religious person, you would try and be very, very cognitive about the fact that you're going into a religious function and system. If you're a scientific person, you will try and stay away, but your whole facet would be, how do I take science over there, right? This is how a baby learns. And I have given you a timeline. If you notice, this is a neuroscientific facet. One of the parts that I straddle between is between AI and neuroscience, but also in terms of how quantum runs it. But have a look at how baby learns. You notice that the first 2 months is only about face tracking, not face understanding. So please understand, the fallacy that you said that it's going to be mother that the baby realizes is absolutely not true. You can put the baby besides an animal as well. The first touch is considered the touch for life, because they have no precognition in their neocortex to say that this is mother or not. It's obviously yes, 99% of the times it is the mother for all species, and that's why it happens to be there. You notice the object permanence happens at the second month, and there's a biological motion obviously that you see in your babies in about three months time. But notice the gravity and the inertia part. 9 months down the line, the baby now knows physics concepts which come as a byproduct to all of you. And you can test it. If you've got a newborn in the house, he's only 9 months old, or he or she, you take the baby up and put them down like this with a larger motion. You will see the baby's arms fling up. Why? They have a cognition of gravity. They know that they are falling. This cognition is not available within machines. Machines don't have this data. And one of my jobs is actually giving machines this data. So what we are doing is essentially giving machines this knowledge so that they become more human-like. They will not become sentient in any response or scenario, but one of the ways is how do they actually start understanding the world around them. Because the machines don't understand the world around them, human beings do understand a lot of world around them in terms of what you do. So that's the reason why I'm actually changing the architecture, me and my team. That's part of my research, that's the big research that is going on in the world. An idea to seed to you for innovation is largely this. You notice a 6-year-old actually can reason with varied vocabularies, and a 17-year-old can reason and drive a car today. And these are some numbers for what we train the machines with. Notice what LLMs are trained on. LLMs are actually trained on a data volume of 1 into 10 to the power 14 bytes, right? Which is exactly what it will take a human 45,000 years to read. When we see this number, we think AI is great. It's got a large amount of data. See a human baby. In the first 4 years, the baby wakes up for 16,000 wake hours. That data volume is much larger than a machine. It's 1.1 into 10 to the power 14 bytes of data that a human cognition has in its human neurocortex, or the new brain as we call it, which machines can never have. This is the kind of gap that we're trying to bridge. This is we're trying to see what machines can dream about. But before machines can dream about, they need to know language. So we are in this world where we are now building world models. You will hear more and more as you heard about LLMs and chat GPTs. These world models will start becoming more clearer to you when you actually see the next year. These world models with a single prompt will actually create the world around you. So the world for simulation, world for games of course, world which is actually telling you how your bedroom should look like. Remember, this is only text that I'm giving. Make me a world that looks like this and change the world as I see it today. World which is completely esoteric, it's got no connection to human life, but a world which is so great in terms of what it can predict, etc. Well, I took the first step of language. Incidentally, Sam Altman, the creator of ChatGPT, was here in India, and he gave a challenge to Indian community saying, can you build a large language model from grounds up and build it under $10 million. Me and my CEO stepped up, and there's a famous tweet, if you guys can go and read about him. He says, from one CEO to another, challenge accepted. I took the challenge up in 6 months. We delivered Project Indus, which is the first large language model of India, in 37 plus dialects in less than 6 months and in less than $400,000. And the whole idea behind this was, when we talk about India, India is so diverse in language and linguistic diversity. You've got 27 or 30 mother tongues now, 1645 dialects which are put in parliament. But this country speaks 19,200 dialects. And the problem comes in when you try and translate. For example, a Hindi sentence saying, मैं पिछले हफ्ते पिक्चर देखी, I saw a film last week. In Hindi is मैंने पिछले हफ्ते पिक्चर देखी. In Marwadi, it becomes लारला हफ्ते मैंने film देखी. All that he changed was पिछले का लारला. If the word and the token is not there known to your AI, the larla, because of Levenstein distance, becomes ladla. Closest word count. If you do not have that token calculated, the word meaning and the sentence meaning completely changes itself. So as a result of that, we had to collect these words. So I sent a team of people in the north of India who actually went with a tape recorder in their hand to every village guy and said, please kuch boliye. And the guy was aghast saying, क्या बोले? I said, अपने नाम के अलावा बाकी सब कुछ बोल दो लेकिन अपनी भाषा में. So he started speaking in Hindi. He said, we don't want Hindi, we want your local dialect. What do you speak in Marwadi? What do you speak in Harauti? What do you speak in Panch Parganya? Where's your Avdi? Where's your Bhojpuri in terms of when you speak? But please do speak your language. That's why we collected this data, and today we are part of a prestigious India AI mission. We are part of the 11 companies who actually are building the LLM for this. Now, couple of last slides. We are imagining, we are positioning machines so that they can dream. They become your imaginative partner. If you just go to dream.ai on Google and put my name, you'll actually figure out this is the next architecture that I'm building with my team. This is the architecture which talks about that when machines can dream about a solution before they even put a solution forward. It's exactly what human beings do. When you take your first step forward, your mind's actually just predicting the next microsecond of that step so that you don't fall down. All that your brain does is predict the next microsecond. There is no other function to do it. I will not go into the consciousness part. I will not go into the religious part. The human neocortex's intelligence is only to predict the next thing to happen. If I pass a ball to you, your reflex is to catch. Here, intelligent brain has not worked. It's basically the amygdala, where a flight or fright response came in for you to attack. Whereas when you talk about intelligent systems, it's just the neocortex that works. One of my ways is to study that neocortex in terms of how to build. I won't go into much detail, but large part of this world has been on the right-hand side, which is the connectionist part of the world. Large neural networks built in, large amount of compute data. What I'm trying to build in is more symbolism with that neural network as well. The two symbols that you see, all of you would have guessed it, it's peace. But where did you get this idea of peace? It's a bird, it's a dove. It's a symbol that is not shown to some of the people, right? So you got this idea of being a peaceful system over there, basically because there was some symbolics taught to you. AI doesn't learn symbolics. So we're mixing the symbolic part with the connectionist part, and we normally call it the neuro-symbolic function. And what we plan to do, and that's the seed of innovation that I wanted to plant in for people over here, is these are some of the things that you can do. Maybe AI imagines the next climate solution. Maybe AI dreams about a new scientific discovery that you've never seen before. Maybe it creates a new art or a new design that was never possible by a human being. And maybe it does all of this with human beings in control in terms of what AI does. So I want to end this with a very interesting quote. Actually, this is a quote from Einstein. I've tried to change this to represent what AI does. So I've actually written over there that the measure of intelligence is not computation. The measure of intelligence would be when machines start imagining, and imagining with courage. So I think when we build these machines, when machines become imaginative, they're not going to kill human dreams. They're going to amplify human dreams. So with that, thank you so much for listening to me.